Okay, again, people are already, most are in the room, but still welcome to the Enhancing Clinical Practice and Outcome stream for SNOMED CT Expo 2022. My name is Yongsheng Gao, Senior Terminologist at SNOMED International. I will be moderating this session. All questions will be asked at the end of the session. Audience here, we will provide the microphone. Online one, participant, please use QA so you can type your questions so we can answer the question later. So I'm now pleased to introduce Sophie Anne Klopfenstein. I'm not sure how to pronounce, apologize, from Charité, Universitätsmedizin, Berlin, that's what I can pronounce, who will be presenting using REDCap and SNOMED CT to collect and structure prospective alarm and patient data in intensive care for alarm research. Sophie Anne, please proceed.
Yeah, thank you for the nice introduction. So my name is Sophie Klopfenstein. I am a medical doctor and a research fellow. I'm currently working at the core facility Digital Medicine and Interoperability at the Berlin Institute of Health, and also in the working group Patient Monitoring and Alarm Management in the Institute of Medical Informatics, both at the Charité Universitätsmedizin Berlin in Germany. So I'm really happy to present today our work on the combined use of SNOMED CT and REDCap for alarm research, and more specifically to collect and structure alarm and patient data in intensive care medicine. And I hope that I get the clicker. So maybe, starting with a quick demonstration. Some of you might already know the sound setting on intensive care units, but for those who don't know it yet, that's just a quick demonstration. You can notice it's quite noisy. There are many devices just ringing from different devices, different rooms, different patients. People, personnel is working, talking, etc. Alarms are designed to inform the personnel about events of physiological deterioration in patients. They may sound, for example, when a medication pump is empty or when a vital sign is dropping or exceeding a set threshold. But not all alarms are technically true, nor require clinical intervention. For example, increasing the oxygen flow after oxygen saturation alarm. These alarms are so-called non-actionable. Alarm management is a very complex socio-technical concept, and the ECRI Institute listed every year between 2007 and 2020 an alarm-related hazard among the top 10 health technology hazards. So you can see it's a very critical problem to address in clinics. Many alarms, and especially of false or non-actionable alarms, are also contributing to a phenomenon called alarm fatigue. Alarm fatigue can be described as a desensitization of the personnel to alarms, sometimes even accompanied by a loss of skills towards the correct management of alarms. Alarm fatigue may harm both patients and healthcare personnel in the end. And that's where we start with our project called INALO, which stands for Intelligent Alarm Optimizer for Intensive Care Units. It aims to reduce the number of non-actionable alarms by using alarm data from monitors, but also patient data from the patient data management systems and deploying afterwards machine learning methods. But to develop those machine learning models, you need structured labeled data, meaning that the data set must be annotated. During the INALO project, we are evaluating several options to annotate the alarm data and classify this, into actionable and non-actionable, both with retrospective but also prospective data methods. So we already got an impression of alarm-related challenges in intensive care medicine, and in today's talk, I will focus on the prospective method to collect and annotate data. I will therefore present the preparation of the REDCap forms, the mappings and evaluation of these, and emphasize on challenges that we encountered during our study. I will end with a quick discussion and an outlook about our future work. So let's start with the preparation of the data capture tool. Based on medical expertise and a literature review, we defined that an alarm is actionable if an intervention is performed within 10 minutes after the start of an alarm to counteract any further physiological deterioration. We specified use cases of interest, such as the decrease of oxygen saturation, and searched for the relevant alarm types for use cases. We listed potential interventions to look for, such as a change of a respiratory therapy type conducted within the 10 minutes after the start of an alarm, and validated all the content. I performed the first steps. I'm myself a junior physician with experience in anesthesiology, intensive care medicine, and interoperability, and a senior physician having completed specialty training in intensive care medicine validated the content. To evaluate which tool we could use to collect and structure thereby the alarm and patient data, we performed a literature review and conducted also several brainstorming sessions. We had several options in mind, such as very old school listing manually events on a sheet of paper or in a customized Excel table. We also thought about developing a software or an application which might also integrate monitoring data, or using REDCap, which has also the possibility to integrate other data or build some APIs. Our requirements were that the tool should support a flexible data entry, meaning that you can code your data with standards, but have still the possibility to use free text nodes. Enable also hybrid way of work, so collaborative work, but also offline work. And the tool should have export functions. Due to time and personal resources, we decided to use REDCap instead of developing ourselves a fully customized application. REDCap stands for Research Electronic Data Capture, and it is a web application to create and maintain surveys, databases, and analyze also data entries. We choose to structure our data collection by creating several forms with so-called fields, meaning questions, and choices, meaning answers. REDCap offers also different features such as branching logic, repeating forms, but also the connection to ontology services. And prior to the annotation, I quickly analyzed SNOMED CT, LOINC, and the Rosetta terminology mapping, a terminology for point-of-care devices, but small teaser, there were no suitable codes, whether in LOINC nor in this Rosetta terminology mapping, so that I focus on SNOMED. So concerning the mapping, as said, we performed the mapping with the aim for precise mapping. We used the international edition of SNOMED CT with, I think it was a version of March 2022. And to store the codes of REDCap, we developed an adapted writing format. And where possible, we also try to display SNOMED CT preferred terms. To evaluate the mapping results, we first counted how many unique SNOMED CT expressions were used to map the content, evaluated also how many pre- and post-coordinated expressions we use for each form and also across the forms. And we use the ISO TS norm 21564, named Health Informatics Terminology Resource Map Quality, or short MapQual, to measure the exact degree of equivalence between the data items from the source, meaning my study, and the target, meaning the SNOMED CT concepts. Each concept is attributed a rating score between 0, corresponding to a perfect equivalence between the source and target, and 4 when no map is possible. Prior to this evaluation, we erased all duplicates, such as yes, no, or split questions, which basically asks for the value either in SNOMED CT or as a free text, and those questions were then considered only once in the analysis. Also, we deleted all duplicates across forms. The average equivalence assessment score is then measured as an arithmetic mean for each form and also across the forms. So now quickly about the results. We defined in total 5 use cases with age-relevant alarm types. We created a total also of 5 REDCap forms with a total of 308 items. The fields or answers have diverse types, such as radio buttons, checkboxes, but also text boxes. Some items are, as I just said, repeating within or across forms, and the deletion of those duplicates resulted in 244 items. Concerning the structure of the forms, each form contains at least a descriptive text about what is the form to be used for, and a text box for comments. Branching logic guides the data entry and provides also some contextual information. The first form, which is called Alarm and Intervention Metadata form, includes also information about the alarm and about performed interventions at a very high level. And when you answer the question whether therapeutic intervention performed, meaning an intervention to counteract physiological deterioration with yes, the alarm is classified as actionable in the databases. The following 4 forms enable you to give some more details why this alarm is actionable. They can be repeated if an intervention is performed several times after a specific alarm, and information about further not pre-specified interventions, either clinical or equipment related, can also be collected in this general form. As I already mentioned, we needed an adapted writing format to store the SNOMED CT codes. In the entry mask, you don't see those codes or the specific writing format. We tried to use SNOMED preferred terms. I think in this example, it was not possible. However, in the designer interface of REDCap, we indicate the abbreviation of the terminology followed by an underscore and by the SCT ID. If it is a post-coordinated expression, the multiple SCT IDs are separated by underscores. And we indicated the codes for the fields in the variable name. So it's on the right top of the form and in the field annotation, and for the choices as a raw value, but also in the field annotation. In field annotation, we indicated also the exact SCT ID and FSN. And the post-coordinated expressions were written using the SNOMED CT grammar. To capture further details or other interventions, we enabled the use of text boxes. And where possible, we created each time 2 fields to capture the content either as a free text or the use of REDCap's ontology services with SNOMED CT being defined or selected. So concerning the mapping, we could map in total 305 items using 262 pre and 43 post-coordinated expressions. 3 items could not be mapped at all with SNOMED CT. And in this table, we focus on the items after duplicate deletion. So we have also a total of 169 unique expressions. 3 could not be mapped at all with SNOMED CT. And we used 129 pre-coordinated and 37 post-coordinated expressions. The items without mapping were alarm pause, alarm discontinued, and acrinol, which is a combination of 2 substances called theradrenalin and caffeidrine, which is authorized in Germany, but not on the US market. With a high average equivalence assessment score of 0.75 for all forms and the best average equivalence assessment score of 0.48 in the form related to ventilation data, we think that SNOMED CT is suitable to annotate the items for our study. We also evaluated the scores for the fields and for the choices separately, but I decided to not choose it or to not show it here because of time. And as said, we think that SNOMED CT is suitable to annotate the items, but we faced several challenges. We saw in sub-analysis that the general alarm and intervention metadata form was performing worse with an average score of 1.52. and especially content related to equipment procedure or alarm mostly needed complex post-coordination to be annotated. Even with post-coordination, those content were not well represented, and this resulted in a very high number of equivalence measure 3 in this area. On the below on the slide, you can also see an example of post-coordination to represent an alarm type called extreme bradycardia. Mostly we used as a pattern finding, then attribute associated with, and then the alarm being a physiological object in SNOMED CT. In SNOMED CT, as said, alarms are represented as physiological objects despite of being rather events. So this produces a shift in meaning. Alarm should be represented, in our opinion, as a deviation, for example, of a parameter below or above a set threshold, without any judgment of the actual value. So here I'm focusing on numeric vital signs. Also, the hierarchies of this physiological objects are very heterogeneous. The items we use to collect further information or details, so for example, other therapeutic interventions, also resulted in a high number of equivalence measure 3, as SNOMED CT is considered being exhaustive, and it is not possible to annotate precisely other concepts. We also think that a more flexible or adapted machine-readable concept model might facilitate the proposed coordination and the creation of new content, especially, for example, to gather information on instant. Also, further synonyms or definitions might be helpful when annotating, especially when you use the browser of SNOMED CT, as some of the concepts might seem unclear when annotating. Concerning REDCap, the tool allows the storage of the annotation and can also be used for study. However, the restrictive writing formats need to be respected. The complex post-coordination might hinder analysis on a later stage with specific statistical programs. And whereas ontology services enhance standardization, they do not support the selection of several codes or the post-coordination with SNOMED CT. So looking to our conclusion, we are currently testing the forms in real-world settings concerning their usability, the feasibility also for data collection. We also want to try if REDCap is really enabling collaborative work and also really working offline. Content requests for changes and additions, both to the national and international versions of SNOMED CT are in preparation. And in the future, we will collect prospectively the alarm and patient data, analyze several data annotation methods, and plan to share the created resources, so both the data collection forms that I quickly presented here, but also the annotated alarm data sets to enable alarm research also for other research groups or hospitals. In conclusion, we think that our approach might enable to share data collection forms to produce a labeled and semantically annotated alarm data set. Besides further developments of REDCap or also adjustments, alarm research would benefit from additions to SNOMED CT content, especially of new intensive care unit content or intensive care medicine content. And pre-coordinated expressions should be requested and hopefully also accepted. And thereby I would like to thank everyone who contributed to this study, and especially thank you for your attention.
Thank you. Sophie Anne is ready for the question. Any question from the audience here? Just check the online. No. Okay. Can I ask a question? Oh, someone here. Okay. Give the opportunity there.
Great presentation. Thanks very much. That looks really interesting. I just wanted to ask whether you, in your approach to post-coordinating the codes, whether you considered other approaches like applying an information model transforming that REDCap data into some sort of information model which could describe the relationships between those codes in a different way.
Yeah, it's a great debate, a great debate at our working group currently. We started with REDCap due to personal resources, but I'm trying also to look to other way to do it, maybe also to combine it with FHIR, as there are also like plugins to convert REDCap and FHIR the data. But yeah, currently we are probably just using this and hopefully maybe also integrate further data if someone could build or develop an API.
Thanks. Any other questions? No? Okay. Can I ask a question? I think you briefly touch on that alarm could be an event. Alarm could be referring to a device that triggered the alarm. And so what was the kind of decision you went for the device rather than events? I know in SNOMED CT, actually events, we only have a very limited model. Was it a reason or you have other particular reason?
So in my opinion, we should have, like, as you said, the devices and events and somehow like a connection between both. Yeah. And some of my post-coordinated expressions, I used also events like notable event associated with an alarm, but it was not always possible. And I tried also to make the post-coordinated expressions as small as possible, but as precise as possible. And I think it was the biggest challenge, to be honest. Another big challenge was also related to ventilation data. And there I went with a very broad approach and tried to be very general, but hope that content will be developed in SNOMED to be more precise and more granular. But yeah, in post-coordinated expressions, I would like to have both the events and the devices to be, to fully code which device triggered which alarm and why was this alarm triggered.
Great. Yeah, thanks for the answer. Because that is not only you are facing that challenge, quite a lot of audience are the more advanced user. They are facing the same challenge because SNOMED CT can't cover everything, but when you need it, how to post-coordinate those, and implementation team are trying to develop the guidance and tooling to help to support this requirement. And as you mentioned in the slides as well, the MRCM, and also we develop, because the content team, we developed a template. For example, if a similar area, you say, oh, these are the similar content, can I add the post-coordination? Actually, you can utilize the template, just fill in the slot, and that new concept that can be created. So gradually we are moving towards that. So hopefully that will help your work as well. Thank you very much.
Thanks.
Okay, so we conclude this session, and if you online delegate forgot this, you can join another session through the event lobby, and people here, if you going for the other session, you can look at the different rooms.